Lesson on this page is going to be volume of prisms, lesson 8-6. So if you'll turn in your journal to your table of contents, you should be gluing this on page 79, volume of prisms. It's 8-6 on page 79, volume of prisms. And we're going to be focusing pretty much on rectangular prisms and triangular prisms. And in the case of a rectangular prism, the example on here is perfect. What it's doing is showing you these little cubes and little centimeter cubes that we have in math classes sometimes. And we want to layer that upon layer upon layer. And that's what we refer to as volume, layering cubes in different layers. And hence, that's why the formula makes a lot of sense when it comes to volume of prisms, because it's layer after layer. So you have a length and a width, and you can see it's pretty much a rectangle or a square shape that's on the bottom, but it has this third dimension, this height. And so when we do length times width, or in this case it's a 4x3, you get 12 cubes on that bottom layer. That's 3, 6, 9, 12. And that's what we talk about, the square units, physically seeing squares. And if you were looking from the top view down, all you would see is squares. But because this has a third dimension, we call this 3D. And so when you go to a 3D movie, you see the flat screen, but sometimes when you put the glasses on, the object comes at you. And that gives it its depth or its height. And in this case, the height of this these stacks here, there's going to be 2 stacks. And so we're going to have 12 cubes on the bottom and 12 on the top, which is just 12 times 2, or doubling 12, which gives you your 24 cubes in the box. So the volume of this container is 24 cubic meters. Now, in the case of what you have to know for this year, is that sometimes the picture that you're given on a test will have the cubes shown, and you have to actually physically count the length, the width, and the height, which is very easy to do. Or most of the time, it just gives you the shape and gives you the 3 dimensions and wants you to figure out how many cubes are going to fill it up. And so today we're talking about volume, which is 3D, 3-dimensional, hence the reason why you have 3 measures. And that's why when we do inch times inch times inch, and a lot of people don't realize this, that you're actually multiplying the units as well separately, that will give you your inches cubed. That 3 right there implies that there were 3 inches that you multiplied. And this is back to exponents. And so when you multiply the 6 times 5 times 8, you get a value that's in cubic units. When we did area before, all the area problems we were doing, it was squared units because the objects were 2-dimensional. They were flat. These objects, as you can see, are 3D, hence the reason why the units are cubed. So if you're ever in a testing situation, you can sometimes look at your answer choices, and if they all have cubed on it, that means volume. And if they have squared on the units, that means area. So very, very easy. And if the units are just singular, just like just inches without the cubic, it's 1-dimensional, and then you're talking perimeter or circumference. So there are ways to look at your answers also and imply what kind of problem you're dealing with. So let's take a look at number 1 here. It says determine the volume of the rectangular prism. And again, on everything we're going to do from here on out, it's usually going to be round to the nearest tenth. So you should be getting really good at that. So once you get used to volume equals length times width times height, it can also simply just be written LWH. And as we go back to and we reflect on our formula chart, and some of you don't use it, this is your best friend on the STAR test. Or any test for that matter with me that you take, is you get to use this formula chart. Oh, I'm sorry, that's me. So I'm taking a look at the formula chart, and I'm going to be looking at volume. And if you notice, it just says prism. So if it's a rectangular prism, it also just says big BH. So I want to clarify something. We need to know what this formula is when we're taking the STAR test, because this is the only formula you'll have. So it does say big BH, and so we want to clarify. So I'm going to write over here that this is generic, big BH. And I want to imply that the B, the big B, does not stand for, little b stands for base, like in triangles and rectangles and parallelograms. The little b stands for the base of the figure. But in the case of when it's a big B, if it's a entirely big B, this means area of whatever the base is. And so you're actually having to do calculations to find that B. And so the base figure, and I'm just going to shade this figure. And on a rectangular prism, the base is wherever you want it to be. I'm going to shade and call this my base. Objects don't have to sit on their bases, especially triangular prisms and other prisms that don't have rectangles. Prisms all have rectangular faces, but their bases happen to be rectangles. So if this is my base figure down here, I'm going to be finding the area of that as my big B. That's why the formula is LW, because the length times the width, this is length and this is the width, gives me the area of that base figure. Now, what they like to do on shapes too is not give you everything that you need on the size that you want. So they're saying that this is 3 meters tall. That means there are 3 levels, and I'm just going to imaginarily draw this in, that there are 3 layers going across this 3-dimensional object. So you can see the 3 layers now. So that means that the height here was 3. So that's what we need for the height. The reason why the 4 over here is to mess with you. If this distance is 4, that means this, and I'm going to shade it right here. This is 4, this is 4. That means that this width right here is also 4. And so sometimes you have to fill in your parts. So the base of this figure, and if I substitute in for big B, would be length times width would be the area of this rectangle. And it's a 7 by 4. So that's the base, the big B. And the height here is going to be 3. So I'm multiplying these 3, and I don't have to have it in parentheses, but I wanted you to understand that the 7 and the 4 is the base, is just the rectangle. So 7 times 4 is 28, and then I'm going to multiply by 3. And this might take more than 3 steps. I'm just trying to draw it out so you can see it. 3 times 2 is 6 plus 2 is 8. So I get 84 meters, and this is going to be cubic. And it's 3-dimensional because you did 7 meters times 4 meters times 3 meters, which is meter times meter times meter, which is meter cubed. I have 3 measurements. Okay. And this is my volume. And that means that it would take 84 meter cubes to fill up this whole shape, the volume. Volume is filling. So when we see the word volume, we think filling. When we see the word area, it's covering an object. If you're covering it with a tablecloth or covering it with sod, which is like grass pieces or squares, if you're filling it like a pitcher or you're filling up a jar or whatever you're filling, that's volume. And you don't see the cubes, but you're filling it with cubic units. But you don't see the cubes. And those little plastic little centimeter cubes actually, when you dissolve them, become a milliliter of plastic liquid. So it can fill an object. Let's take a look at this object here. And again, you can name this the base whatever you want. Just for the sake of being different, I'm going to call this front shape my base, just so you can see the difference. If I call this front face my base, which I can. So again, objects don't have to sit on their bases. Because it's a rectangular prism, I could call any of these sides my base. It doesn't have to sit on it. I know a lot of people like to pick the one that's on the bottom. It doesn't really matter. So volume equals big BH, and that will be your generic formula every time. The big B is the area of the base figure, and it happens to be a rectangle. So that means it's length times width, which is the base, times the height. The length is 3. The width, and because it's standing upright, I know some of you think that's the height. It doesn't have to be. Just picture that this object gets flipped over and dumped on its bottom part here. So it's a 3 by 2 by 2.7. So basically just understand that on volume, when it's a rectangular prism, you're just multiplying all 3 different dimensions. You should have a length, a width, and a height. 3 times 2 is 6 times 2.7. So I'm going to do 2.7 times 6. 42, 12 and 4 is 16, move the decimal 1 place. So you get a volume of 16.2 feet cubed, and you're done. Length times width, then times height, or big B times H. Okay, so you're going to fold that up and you're going to glue that in on the page that was written there. Oh, and on table of contents, I just forgot, this is 2 pages today. So let's go ahead and add page 2. So that was page 79, and then so 80, I should have done 79 to 80. Oh, well, this is going to be volume of prisms as well. And we should have enough room here. So this is page 2. So these go together, page 1 and page 2. You'll glue them on separate pages. So you're going to use page 79 and page 80. So we're going to fold that up and we're going to put that on the page it belongs on. And we've got two more problems because we're going to talk about triangular prisms. And so in the case of this, when you look on your formula chart again, it's still only going to say V equals big BH. So in the case of a triangular prism, and how do you know it's triangular? It's because its bases are triangles and they'll be opposite of each other. So basically it's taking a rectangular prism and cutting it in half because that's all a triangle is. So if I want the volume of a triangular prism, and I'm going to write triangular prism, I have to know, and you have to know, that I'm going to half my base times height. So anything that deals with a triangle is half of a rectangle. That means the rectangular prism is going to be halved. Okay, and so we're going to take this and we're just going to apply the formula and we're going to say, okay, volume equals, and make sure you put the 1/2 in front. It isn't, and you got to know it's a triangular prism. Does it have to be sitting on its bases? No. In the case of this triangular prism, it is sitting on its bases. And I know I'm shading this one, but the bottom and the top should be identical. So I can call that a base. The other one's a base. You have two bases on rectangular or triangular prisms. The case of this one over here, the base is standing upright. It's not sitting on its base, it's sitting on its rectangles, but everything else is rectangles going around. Everything is rectangles going around this. We call that the lateral surface area, and we'll be getting into that very soon because we'll be calculating surface area. So we're going to do volume equals 1/2, and again, the base. The base is a triangle. I'm going to write here, base equals triangle. And the area of a triangle, so you got to find area of a triangle, and that's when you look on your formula chart and it says 1/2 little bh. And the little b means the base of the triangle, not the base of the shape. The base of the shape's area is 1/2 bh. So there's actually two halves here that it may look strange, so you got to be kind of careful with that. Okay, so we're going to go ahead and we're going to calculate and continue on. So 1/2, the base is a triangle, 1/2 BH. Okay, here we go. Okay, so I'm trying to get ahead of myself here. It is 1/2 little BH. So the formula still is big BH. We don't need this 1/2 here yet because I went a little too far with that. This should be little BH. It's 1/2 base times height. So that's the triangle itself. And then you're going to multiply, and that's the formula for the base times the height. So we're going to fix that up just a little bit. Made a little mistake there. Getting ahead of my brain here, getting a little fast on myself. So volume is still big B, little h. And then we know that the area of the base is 1/2 little b h. That 1/2, I put too many 1/2s. You don't want to half it again. So if you do 1/2 little bh, that's the area of the triangle. And then you're going to stack those triangles times your height. So again, it's stacking of cubes. So 1/2 base times height will give you the area of the triangle. And then you're going to stack it in layers 15 deep. Sorry, I apologize for that. You had to go back and fix it. So we're going to go 1/2 BH times the height. And so in this situation here, we're going to say, okay, I have 1/2 times the base of the triangle. And these are your two dimensions. And all you got to do is look for that right angle and remind yourself that the right angle is where the height and the base form a 90-degree angle. And that's how you know which one's your base and your height. And they're interchangeable, so it doesn't matter which one you use. Make sure you don't use the side that's opposite the right angle because that's called the hypotenuse and it's not the side we want. So we're going to do 4.8 and then times the height, which is 9.6. So it's 1/2 because this would have been a rectangle coming off of here and we have to find that area, and then we're going to do times the height. And again, the height is the rectangles and how tall they are. And so that's 15 tall. Okay, so here's our whole formula here. And honestly, it doesn't matter what you take half of as long as you can take half of something just to make it smaller. I could half the 15 and get 7.5. I could half the 4.8 or I can half the 9.6. I think I'm going to go ahead and half the 4.8 here because half of 4 is 2 and half of 8 is 4. And that just gives me 2.4 times 9.6 times 15. Now, next year, this will be really nice because you'll get to use a calculator to do all your calculations. But today, we got to do it by hand. So we're going to go ahead and go 9 6/10, and we're going to multiply by 2 4/10. And we get 24 carry 2. 36 and 2 is 38. 0, 12, 18 and 1 is 19. you get a 4, 10, 9, 10, 11, 12, 13, carry 2, and you got 2 places, I forgot my memory cloud there, to move my decimal. So then I take my 23, and by the way, don't round to the nearest tenth till you're done. So I take my 23 and 4/10, and I'm going to multiply by 15 because that's the last number left to go. I do have 2 places to move my happy memory cloud. So I'm going to do 4 times 5 is 20, carry 2. 5 times 0 is 0, plus 2 is 2. 5 times 3 is 15, carry 1. 10 and 1 is 11. I hug and I kiss. When I multiply by 1, it's simply the digits you see. I got 4, 0, 3, and 2. These carryovers don't carry over for the second round. 6, 5, 4, and 3, and move my decimal 2 places. So you do get 345 and 6/10, and I don't have to worry about the 0, and I'm rounding to the tenths. So my answer is 345 and 6/10 inches cubed. Okay, let's take a look at the last one over here. We're gonna be working with a triangular prism again. This time the bases are on their sides, tilted over. So just a reminder, we're gonna keep this separated here. And I probably should have put this on the other side, clean that up just a little bit. There we go. And we're gonna deal with this triangular prism. And again, the volume formula is still big BH. It just happens that the base figure is a triangle, so I use my formula 1/2 BH because that's for a triangle, and I'm just going to remind myself it's a triangle. And then the height of it all is how tall it is. Now the height of this is sitting on its side, it's the rectangle height, and I can picture I'm stacking triangles like this in layers. And if you want to, you can kind of draw it in so you can see it. I got 3 layers of those triangles going back, so that's my height, even though it's sitting on its side. And I'm going to do volume equals 1/2. The base of the triangle is 7.2. It's where the 90-degree angle is, and the height is 9. And I'm going to multiply by 3. So I've got all these things to multiply. And again, multiplication order doesn't matter. So you can half anything you want here. I can half the 7.2. If you don't know how to half it, you're just dividing it by 2. You can go off to the side and try it out. And I get 12, and I get 3 and 6/10, and I'm going to multiply that by 9 and by 3. And again, order doesn't matter. I'm going to do 9 times 3 is 27, and then times my 3.6. So 27 times 3.6, happy memory cloud of 1, I get 42. 12 and 4 is 16, 0, 21, 6 and 2 is 8, and I add those together. 8 and 1 is 9, that's a 9. So 2, 7, 8 and 1 is 9, and move my happy memory cloud 1 place. So my volume here should be 97 and 2/10 meters cubed. And so now we've calculated, just a reminder, if they're triangular prisms, you've got to half the base figure, the half of the B, and then multiply by the height. If it's a rectangular prism, it's just length times width times height. Make sure you get this glued into your journal on both pages 79. This page right here goes on page 80. Just make sure that you're getting it into the journal there, and make sure you're asking questions and rounding your answers to the nearest tenths. All right, until next time, we'll see you guys later.